Hi, I'm John Wesley Ephraim from the Enhanced Regenerative Medicine Lab at Instituto Italianoli, Technologya, Italy. The ultimate goal of our research is providing new solutions to enable healing patients affected by mesial temporal lobe epilepsy, MTLE, the most common form of epilepsy in adults and the most often drug refractory. MTLE is characterized by hippocampal dysfunction and may lead to cognitive and psychiatric disturbances. The hippocampus is a highly excitable brain region known to generate synchronized rhythmic activity, likely making it prone to seizure generation. Here I am presenting our discovery of the spontaneous emergence of the epileptiform patterns in vitro hippocampal spheroids. An established in vitro model of MTLE is the rodent hippocampus cortex slice treated with the convalescent 4-aminopyridine, in which the shuffle collateral disruption mimics hippocampal damage seen in MTLE patients. However, this model enables acute studies only, and it requires high number of animals. In the effort to both reduce and replace animals, we recently proposed hippocampal organoids derived from rodent neural stem cells. These enable to speed up in vitro studies compared to human brain organoids. Nonetheless, all organoids require elevated costs of growth factors, and robust functionality is still an open challenge. Thus, our purpose was exploring the potential of primary hippocampal neuron-derived spheroids to recapitulate the pathophysiological hallmarks of MTLE epileptogenesis and ictogenesis. To this aim, we established a two-step protocol using isolated hippocampal neurons from E17.5 rat embryos. We first promoted cell self-aggregation into ultra-low adhesion well plates and then moved the spheroids into the agarose-coated well plates to address maturation. By bright field imaging, we observed the spheroid growth across time, showing a peak at div 14 with an average diameter of 500 micron, after which no significant growth was further detected. Next, we adopted 3D microelectrode array electrophysiology to assess the spheroid functional profile through development. We observed a reliable functionality across different batches and a widespread activity throughout the electrodes in contact with the spheroids at all time from div 10 to div 35. Further, the number of active spheroids increased through the development. Importantly, the spheroids generated three main patterns of activity. At early stages of development, the spheroids generated interictal-like events only, consisting of short population bursts. At intermediate stages, the electrical pattern transitioned to a mix of interictal-like events and long-lasting ictal-like events equal or more than 20 seconds. Finally, at late stages, we observed robust ictal-like discharges lasting more than 60 seconds. These patterns could be distinguished based not only on their electrographic features but also on their duration and interval, as shown in panel B and panel C. Further, the probability of observing each of these patterns depended on the spheroid maturation stage. In particular, the electrographic features of ictal-like discharges generated by late-stage hippocampal spheroids resemble those of ictal-like events generated by 4AP-treated hippocampus cortex slices, being typically initiated by slow interictal-like events followed by a tonic-like and a clonic-like electrographic components. To conclude, here I illustrated a highly reproducible method to generate and maintain long-lasting in vitro hippocampal spheroids displaying a functional developmental profile and spontaneously acquiring features typical of epilepsy. In this regard, we are currently assessing the analogy between the rat spheroid functional profile and the human MTLE electrographic features. Overall, our data demonstrate that hippocampal spheroids are a cost-effective alternative to animal models for developmental studies as well as for investigating epileptogenesis, ictogenesis, and targeted therapeutic strategies. This work is funded by the European Union through the Fed Proactive Project Hermes. Thank you for your attention and don't hesitate to reach out to me for any comments or questions.